Hello dear students, this is Engineer Akib Ahmed from Department of Civil Engineering UT Peshawar. In today's tutorial, we will discuss about the material assigning to structures or defining material for strut walling and sheet pile wall, the structure elements. So first of all, we have to open the Plaxis. This was our previous project in which we defined the borehole and also created material data sets for the soils. Now after that, we have to move to the structure mode and click on the material to select material for the structures. First of all, we will select the soil and interfaces set type. Now after that, we will select the for struts we will select the beam. Okay, new. For this we will assign the identification name, that is strut, S-T-R-U-T. This is our color for the strut. I want it to be green. Material type for the strut will be elastic. Now modulus of elasticity for the strut is 2.1 multiplied by 10 raised to power 8, and the unit weight for this strut is 78.5 kilonewton per meter cube. 78.5. And the beam type is a predefined, and it is massive circular, or no, it's predefined, it's user defined here. Now we have to enter the area for the beam. So the area for the beam is 0.00736767. The moment of inertia in second direction 5.073 multiplied by 10 raised to power minus 5. Okay, so the moment of inertia in other direction is also 5.073 10 raised to power minus 5. So this is a symmetrical section. Okay, now our strut material is assigned created. I will click OK. Now we have to define the walling for the this project. So we will select beam, new material, and we'll select as walling, V-A-L-I-N-G, walling, and I want to, the color of this should be yellow. Now properties, modulus of elasticity for walling is 2.1 multiplied by 10 raised to power 8, and the material type is elastic as given in the tutorial manual. So the unit weight of this walling will be 78.5, and beam type should be user defined here in this project. The area for the walling is 0.008682. Moment of inertia in one direction it is 3.66 multiplied by 10 raised to power minus 4, and moment of inertia in other direction it is 1.045 multiplied by 10 raised to power minus 4. Okay, so the walling material is also created. I'll click OK. Now after that, we will create material for ground anchors and grout. So after that we will select anchor, new. So the ground anchors, we will name it as NODE node 2 NODE node anchors, node to node anchors, and I want its color to be black. Okay, it's okay. Now material type for this anchor will be elastic, and the axial stiffness is for this node to node anchor is 6.5. it is given in Plaxis 3D 6.5 Plaxis 3D manual. So this axial stiffness in Plaxis 3D manual for this excavation in sand project and node to node anchors. So the property for this axial stiffness for the node to node anchor is 6.5 multiplied by 10 raised to the power 5 positive 5. Okay, now the node to node anchor is also created. Okay, now after that we have to also define the ground body, which is an embedded beam. So we click here embedded beam, new, and we will enter the identification name for this grout, BODY, and color I want to select for this is red. Material type for this grout should be elastic as given in Plaxis 3D manual, and modulus of elasticity for this grout body is 3 multiplied by 10 raised to the power 7, and unit weight for this is 24. The beam type here is predefined and massive circular beam, it's okay. Now diameter of this grout is 0.14 meter, 0.14 meter, and the area for this and moment of inertia for these grout bodies selected automatically by the correlation with the with these diameter and stiffnesses. So now we have to enter the axial skin resistance. So at T skin start, so at start it should be 200 according to tutorial, and at end it should be 0, and base resistance given in Plaxis 3 is 0.0. Okay, so the grout body is also created. Okay, now another material, the sheet pile wall. We have to create sheet pile wall for our project. We will also discuss the use of all these materials further in other tutorials when we will create the structure elements and walls and struts, beams in the project. Now in this tutorial we are just defining materials for all the structure elements. Now we have to define plate element for wall, and we will enter as sheet pile wall, and color for this I will select as this. So we have defined the sheet pile wall as a plate, so I selected this color. Material type is elastic and non-isotropic. So the depth for this sheet pile is 0.379, and unit weight for this is 2.550. Non-isotropic, so we have to uncheck this isotropic checkbox. We have to uncheck that, so it is unchecked. Now E1 for this is for 1.46, 10 raised to power 7, it's okay. Now E2 is 7.3 multiplied by 10 raised to power 7.3 multiplied by 10 raised to power 5, and Poisson's ratio is 0. So shear modulus 12 is 7.3 10 raised to power 5. Now shear modulus for this is 1.27 multiplied by 10 raised to the power 6, and shear modulus 23, it is 3.82 multiplied by 10 raised to the power 5. Okay, so sheet pile wall is also created. So for now it is enough for this tutorial. In part 1, excavation and sand part 1, we created the borehole and also the soil material. Now in part 2 we have been created the structure elements materials. Now in third tutorial we will make the structure in the project, and we will assign different elements, structure elements, struts, walling, sheet walls, etc. To the structure. We will make the structure elements and we will assign these materials to them. So for now this is enough. Thank you for watching. Please like the video and subscribe the channel.